You made it to the last unit, so good job. You've got, including today, 6 more classes to be together. So what we're going to do today is sections 6.1 and 6.2, or no, 7.1 and 7.2 in our book. So section 7.1, what we're going to do is, it's likely you have seen and talked about these things before, but I treat them as if you have not, because they're going to be so important when you get to college algebra and when you do other things. So what we're going to do in section 7.1 is we're just going to do an introduction to radicals. Okay, my hope is that as we're going through this, you're like, okay, I've seen all this before, but I'm doing this just in case, because I don't want to make any bad assumptions. So in case you don't know what a radical is, okay, a radical is a symbol that looks like this. It looks like a check mark with a roof on it. Okay, this is called a radical. And what it is it's a symbol for an operation. Okay, so it's an operator symbol. Like a plus sign or a minus sign or a division sign. It's telling you to do something. And that's what we're going to talk about in this section, is what is it telling us to do? Just a couple other things that I want to tell you about the radical before we get to that. In the little basket right here, sometimes you will see a number, okay? And so I'm just going to put a little n there. That number is called the degree of the radical. It also tells you to do something, okay? So it is important. Sometimes, or a lot of times, because the degree of 2, it's not the degree of the radical. Oh, I already goofed up the video. I should restart. Sorry, not the word degree. I was thinking powers. It's the index. Sorry, index of the radical. That's better. I'll be a good professor someday. If the index is 2, okay, a lot of times it won't be written. If you have an Apple phone and you use your calculator, they do put the 2, because other parts of the world do use the 2. In the United States, typically in math, if there's a 2, it's just implied. It won't be written there. I don't care if you write it or not, whatever you feel comfortable doing. So if the index is 2, it doesn't tend to get written. What is under the radical? The word for that, I'm not going to have a vocabulary quiz or anything like that. I'm just giving you this so that if I happen to use the words, you know what I'm talking about. So whatever's under the radical is called the radicand. Okay, so that's what comes under the radical. So for instance, the context that you'll see a radical in is something like this. If I put a radical and then a 25. Okay. So for this first one, I will put in the little 2 right there. I don't tend to write it. Okay, so here's what the radical is asking you to do. It is asking you, is there a number that you multiply by itself 2 times? That's what the 2 tells me. Is there a number that I can multiply 2 times to get 25? And what is that number that we can multiply 2 times to get 25? 5. And again, I'm almost positive everyone has seen the concept at least of this. So here's what I would like you to do, just to make sure we're all on the same page. Okay, here's some radicals with index 2, and I would just like you to calculate what the values are for me. Okay, so this is radical 81. Nope, not 88. 81, that's better. Radical 144, and then radical 49 over 36. Okay, so I'll give you 30 or 45 seconds to write down what those are. I know your calculator will do it, but for these first few, let's warm up our brains. Okay, so I have not written a number in the basket, so each of these has an index 2, so that tells you we're looking for numbers times themselves 2 times. So what times itself gives you 81? Perfect, thank you. 9 times 9 is 81. What times itself gives you 144? 12, great job. The fraction I put up here just so that you know that, don't be intimidated. I know we hate fractions, but when you have it there, just consider the top and the bottom separately. So the square root or The radical 49 is what? 7, and then 36 is going to be 6. And I said the word, I was going to say it in a second. When the index is 2, what this is called frequently is the square root of a number. So all numbers have a square root, or all positive numbers have a square root. It's just we're looking at ones that turn out to be nice whole numbers in our answer. So I can change the index. Okay, that's where the fun starts with our radicals. So now if I change the index, so I've got radical 27, but instead of an index of 2, I'm going to put a 3 right there. So the purpose of this problem is just to remind us what the index is telling us. So now I want a number that I multiply by itself how many times? 3. That's what the index is telling me. So what times itself 3 times would you guess is going to give me 27? 3 times 3 times 3 is going to give me 27. That's great. So here's a few for you I would like you to do. So this is called, when the index is 3, it's called the cube root. So what is the cube root of 64? What's the cube root of 125? And then what's the cube root of 1 over 8? Okay, so the cube root of 64, what do you get when you take the cube root of 64? 4. Cube root of 125, what do you get when you take the cube root of that? 5 times 5 times 5 is going to give you 125. That's right. 4 times 4 times 4 gives you 64. So those are my cube roots. And then over here, the cube root of 1 over 8. So again, top and the bottom. What's the cube root of 1 in the top? 1. And then what's the cube root of 8 in the bottom? 2. Is everyone tracking with me on where these numbers are coming from? Any questions, anything you have for me? Okay, well, let's expand our knowledge here just a little bit. All of the radicals we've done so far have been what's called the principal root. So for instance, my first example was the square root of 25, and you told me that was 5. Okay, this is the called the principal root. What that means is it's the positive one, and that's what our radical symbol is asking for. But we know that 5 isn't the only number times itself that gives 25. We could say negative 5 times negative 5 would give us 25. Okay, so as far as mathematical notation, when the negative answer is desired, instead of guessing, what you would do is you put the negative out in front. So if you see the negative out in front of your radical, it's asking for the non-principal root. You don't even really need to know the terminology. You just need to follow what it's saying. So I'm just going to cover up with my thumb the negative there, and the square root of 25 is 5, and then I just bring the negative over and I get negative 5. Okay, so there's nothing really for you to have to memorize there other than when the negative is outside, you just bring it along for the ride. But there is one problem that we encounter at this point in our math careers when I have a negative. If I have a square root, but this time instead of being outside the radical, the negative is underneath the radical. It's part of the radicand. So now what I'm asking for is what number times itself is going to give me negative 25? And what would you propose? Okay, so I heard what I expected to hear, and I love it. 5 and negative 5. Here's the problem. To get a negative number, we need to have a positive number and a negative number. Are these the same number? No, they're different, right? And so what the radical is asking for, when you see it, it's saying, what is the same number times itself? These are different, so that's the problem. So for right now, until we get to the very last section of this unit, for right now, when you see a negative underneath your square root, or let me just make a note, anything with an even index, then it's going to be not defined. In the last section of this unit, we will define what that is, that there is actually something there, but not just yet. We're just talking about the radicals right now and what they're trying to tell us. Now, cube roots. So cube roots, as an example of an odd index, okay, my cube root, can I multiply something times itself 3 times to get a negative 27? What would that be? Well, 3 is going to give me 3 times 3 times 3 is positive 27. So how do I have to adjust this? Okay, well, let's see. What if I make it negative 3? Will I end up, when I multiply that, with a negative 27? Well, the first one, negative 3 times negative 3, what do I get when I multiply those two things together? Positive 9. And then 9 times negative 3, what does that turn out to be? Okay, so this is what this tells me. When you have an odd index, meaning this number in the basket is odd, like 3 or 5 or 7. When you have an odd index, it's perfectly legal to have a negative number under there. So the cube root of negative 27 is negative 3. So at this point right now, there's a difference. When the index is even, meaning I'm multiplying the number times itself an even number of times, if there's a negative under there, we can't do it, okay, right now. It's not defined. When the index is odd, if you have a negative number under there, that's fine. You're just going to get a negative answer. Okay, so it's important to note the difference between those two things. So here's just a few examples just to follow up, give you the opportunity to ask any questions that you might accumulate so far. Okay, in case you are not as familiar with this as I'm assuming you are. So don't let me get away with it. So write down, this is square root of negative 81, the cube root of negative 1,000, and then negative square root of 100. Please write down your response to those. All right, what did you write down for the square root of negative 81? Okay, not defined. Cannot determine a value when you have a negative underneath an even index. The index here is 2. How about the cube root of negative 1,000? Is there something times itself 3 times that will give me negative 1,000? Negative 10. Don't be afraid to mess around with your calculators to figure out these numbers. And as an aside, most of your scientific calculators will do cube roots and fourth roots and fifth roots. If you don't know how to do that, just see me after class. It'll take us literally 5 seconds to find the button and to show you how to push the buttons to get these roots. Okay. And then finally, negative square root of 100. What does this one want? Okay, negative 10. The negative's outside the radical, so the negative just follows along. Okay, so I've not violated what I told you about even indexes. So note the difference when the negative is under the radical versus when it's outside the radical. Up to this point, are we doing okay? All right, well, I gave everybody a sheet when you walked in. If you're watching the video, it's in Canvas, it's the next module, you can print it out. It is a supplement because for this next thing, there's not as many problems in my math lab as I'd like. So this is just for homework for you. The answers are on the back. So when you're doing your homework over the next couple days, but what we talk about, we've mentioned this word a couple times in this class throughout the semester, the idea of domain. The very first section of Unit 2, we talked about what a function was and what the domain of a function was, and the domain is the x values. Then in the last unit, when we talked about fractions, we talked about the domain, and that was part of your test, and you're going to get those back. And in fact, most everybody did pretty good on the domain part of the test. I was pretty impressed. So now we're going to talk about what's the domain if I have a radical expression. So for instance, what happens if I have something like this, the square root of x minus 3? And I'm asked to find the domain. So I'm going to divide this up into two parts, and just like the sheet I gave you. Let's first talk about if there's an even index, and then we'll come back and we'll talk about if there's an odd index. Now at this point, and it's still on the board, what can I not have under the radical if it is an even index? Cannot have a negative. Okay, just to repeat, just because of this, the radical says what is the same number times itself that gives me this. If this is negative, that means I need different numbers. I need a positive and a negative value. That's the problem. And so this right here, what's under the radicand cannot be negative. So when you are asked to find the domain and the index is even, meaning the index is a 2 or a 4 or a 6 or whatever, an even number, then this is what you do. You scoop out the radicand, the x minus 3. And you say, okay, that can't be negative. So the mathematical way to say something can't be negative is to say it has to be bigger than or equal to 0. You think about the number line, anything that is to the right of 0, anything that's bigger than or equal to 0, those are the positive numbers. Well, this gives us, the next couple of problems give us the opportunity to review solving some simple inequalities, because final exam's coming up in a couple of weeks. So all I'm going to do here is add 3. And I get that x has to be bigger than or equal to 3. Now we'll write this in interval notation. If all of my values, if all of my x's are bigger than or equal to 3, everything is bigger. Does that mean 3 is the lower limit or is 3 the upper limit? Lower. If everything is bigger than 3, then 3 is the smallest number. So 3 is the lower limit. And then what's the upper limit according to what I have written here? Yeah, there is no upper limit. Everything is bigger than 3. So infinity. And when we talked about this, we said always at infinity, what do I put? A parenthesis. And on this particular problem, since I have an equal bar in my inequality, I'm going to put a bracket at the 3 end. And there's my interval notation. So I just want to summarize. If you have an even index on your radical and you're asked to find the domain, what you do is you take whatever's under the radical, the radicand, and you say that has to be bigger than or equal to 0. So here's one for you. I would like you to please find the domain of this right here. If I give you the square root of 12 minus x, please find the domain and write it in interval notation. Yeah. Yes, it does, because if I'm telling you that this can't be negative, it cannot take on a negative value, that means that all the values this has to be bigger than or equal to 0. So number line, here's a 0. These are the negative numbers. These are the positive numbers. If I'm saying that this x minus 3 has to be not negative, so it means it has to be positive, that means it has to be bigger than or equal to 0. It has to be on this side of the number line. Because you can take the square root of 0. So the question, in case you didn't hear it, was how do I know if I use an equal sign or if I just have a greater than without the equal? You're always going to use an equal sign because the square root of 0, what number times itself gives you 0? 0. Okay, so you can have a 0 underneath the radical. Okay, so starting at 0 and all the positive values you can do. The negative values, that's where we have problems. I erased it, but I have the square root of negative 25 over there. So you're asked to find the domain of this. There's an even index. The index is 2. So what do I write down next? How do I find out what the domain is? 12 minus x is what? I just didn't hear. Greater than or equal to 0. Yes. Greater than or equal to 0. Please use this sign because in this problem I gave to you, we have a negative in front of our x. And this is going to give us a chance to review the one difference solving an inequality versus an equation. So first thing I'm going to do those, I'm going to subtract 12 from both sides. So that sounds great. And I have negative x is greater than or equal to negative 12. And then to solve this, I divide by negative 1. And what is it that I have to remember when I solve an inequality? If I divide by a negative, what do I have to do? You got to flip the inequality sign. So instead of a greater than or equal to, because I have to flip the sign, it becomes less than or equal to. So x is less than or equal to 12. Now this less than, I know I just answered the question, how do you know what sign to use? We always start off with a greater than or equal to. This one flipped because I had a negative x. Okay, that had nothing to do with where I started. So now all of my values are less than 12. So if everything is less than 12, is 12 the lowest value or the highest value? This time 12 is the highest value. And that means negative infinity is the lower bound. And so we always use a parenthesis at infinity, and then we use a bracket at this side. I'm going to have you do just one more because this is again, I'm trying to prepare you for going to college algebra, finding domains. We're going to do a lot of graphing there. And this is when we talk about the graph of the square root, this is going to be a big part of it. Yeah.
Okay. I have a question because when I took out the radical for that one right there, I took the negative to the x, and I got the same answer. I just did it differently. I put negative x plus 12. And then it did it here.
Yeah, it's the same thing.
The same answer. I just want to like if I did the other.
So you said that, if I'm understanding right, you started off with negative x plus 12 is greater than or equal to 0, correct? Yes. So you can put terms in any order. So as long as your negative stays with the x and the 12 is still positive, you can put terms in whatever order that you want. Yes. All right, here's one more just for fun. So please find the domain of this. Let's say I give you a fourth root of 2x plus 7. All right, once again, I've got an even index. It's 4 this time instead of a 2. Doesn't change anything. When the index is even, you cannot have a negative under the radical. So again, I'm just going to take this 2x plus 7, and that has to be bigger than or equal to 0. No choice. So we'll solve this. Any questions? Are we doing okay? So I'm going to subtract 7. And I get 2x is greater than or equal to negative 7. I'm going to divide both sides by 2, and I get x is greater than or equal to negative 7 over 2 or negative 3.5, whatever you like. So once again, all of my values are bigger than negative 7 over 2. Everything else is bigger. So that means negative 7 over 2. Is that the lowest part or the highest part? The lowest. If everything's bigger, that means that's the lowest. So my interval starting at negative 7 over 2. It's going to go to infinity. We always use a parenthesis at infinity. And again, there's always going to be an equal bar on the domain of a radical. So I put a bracket there. That's what we do when there's an even index. Now, you might be thinking, okay, that sounds great. I get that. We did an extra example. Didn't really need to. What happens if I have an odd index that we're asked to find the domain? So again, we're still finding the domain here. Let's say that I have the cube root of x minus 19. If I have the cube root of x minus 19, again, let's just go back in time, 6 minutes. Okay, 6 minutes ago, we did this problem, and I said, okay, what's the cube root of negative 27? And we realized, because of the way negatives work when you multiply, that we could take the cube root of negative 27. It was negative 3. So we saw, oh, we can have a negative when the index is odd. So what you're going to do, this is nice, there's no figuring, you don't have to do anything. If you see an odd index, then your domain is always going to be this, negative infinity to positive infinity. You don't have to do anything. This means you can plug in any number. It can be positive, it can be negative, it can be 0. It doesn't matter, because I can take the cube root or any other odd index. I can take the cube root of any value, positive or negative. So final domain problem, and then we will wrap up this section, this introduction to radicals and radical expressions, is find the domain of this. If I say the 5th root of 4x minus 9, what is the domain of that? And what'd you write down? Perfect. Negative infinity to positive infinity. As soon as you see that the index is odd, when I ask you to find the domain, there's nothing else to do or think about. You can plug in any number at all for odd index. Okay, so that's the distinction. That's why I gave you some extra problems to work on that sheet, is because there's only like one in my math lab. And I'm going to put, I guarantee you, put an asterisk. I am going to put at least 2 domain problems on the next test. Okay, so if you can do this right here, then you're going to get some problems right. Okay, so keep that in mind. All right, finishing out this section, this introduction to radicals and radical expressions. We've already kind of broached the topic, but we've done square roots when the index is 2. We've done cube roots when the index is 3. In this class, those are going to be the most popular indexes you see. But just in case, let's say that I have a 5 as the index, 5 radical 2. Okay, so the 5th root of 32. Well, now this is asking, is there a number that I multiply how many times this time? 5. And what number times itself 5 times? It's going to give me 32. Yeah, it's going to be. You can see that when the reason higher indexes we don't do a whole lot with is the numbers get big really fast. Okay, and I'm not here to torture you. I just want to see if you can understand what the radical is communicating to you. So 2 times 2 times 2 times 2 times 2 gives you 32. So when I take the 5th root of 32, it's just equal to 2. So here's 3 examples for you just to kind of finish up our time together. So I would like you to do this. So let's say that you have the 4th root of 81, and then the 4th root of 1 over 16, the 5th root of 243, don't be afraid to play around on your calculator if you need to, and then the 5th root of negative 1 over 32. All right, what times itself 4 times is going to give you 81? 3 times 3. So 81 is 3 times 3 times 3 times 3. So the 4th root of 81, that's 3. Something I didn't mention earlier, I'm going to mention it now. I'll mention it as we go through. Once you have taken the radical, once you've done the operation, you do not need the radical anymore. Okay, sometimes I'm going to go back in time. We did much earlier the square root of 81. And when we did that, you told me the square root of 81 was 9. But sometimes, because 9 is a fun number that's 3 times 3, sometimes students carry along the radical and say, oh, then the square root of 9 becomes 3. And that's wrong. Okay, once you have used the radical, just like a plus sign or a multiplication sign, once you've used the operation, you do not need the radical on the other side anymore. It's done. Okay, so just keep that in mind. I know sometimes numbers look tempting. What number times itself 4 times gives me 1? Yeah, that's nice. What number times itself 4 times is going to give me 16? Oops. Well, there you go. Request your money back. Sorry, everybody. I know you were messing around with that. That should have been 243. I think I said 243, but wrote 245. I'll check the video later. So this should have been the 5th root of 243. My apologies. So I'll come back to that in a moment. And so this is the 5th root. I've got a negative underneath. Well, since the index is odd, we can have that. So it means my answer is going to be negative. And what number times itself 5 times gives me 1? What number times itself 5 times gives me 32? Well, we've already seen that, 2. And so we've got negative 1/2 on that one. And so sorry for the typo. The 5th root of 243. What number times itself, if you had to hypothesize right now without thinking about it, is going to give me 243? 3. Okay, 3 times 3 times 3 times 3 times 3 is going to be 243. So the 5th root of 243 is just 3. Again, the reason we don't use larger indexes a lot is because the numbers get big very fast. Yes?
So if it's an even, index and it's negative.
We would write not defined, yes. Even index with a negative under it, it's not defined. That's why when we found domains, it had to be bigger than or equal to 0. And if it's an odd index, doesn't matter. You can have a negative under there, that's totally fine. Great question. It's good to be clear on these things. Any other questions before I stop this video and move on to section 2? All right, then I will do that. Let's stop this video.